Possessing approximately 220 million acres of marine resources itself, the island of Ireland is situated at the forefront of Europe's marine environment. Based in Galway is the Marine Institute of Ireland, whose responsibilities are to carry out marine research and to develop new technologies as part of its role in safeguarding one of our most precious of resources.
Well, the Marine Institute was founded in 1991. Various functions, but I suppose the key ones are our role is to facilitate and support marine research, but also we're a state agency, so our other role is in terms of providing marine scientific services to government, particularly to the Department of Agriculture, Fisheries and Marine, but we also work closely with other agencies such as the Environmental Protection Agency, other departments such as the Department of the Environment.
Since the early 1990s, one of the main marine surveys that is carried out is in Irish coastal waters. This survey provides information on the current status and changing conditions for key environmental variables. Each survey is designed to collect a range of data from temperature and salinity levels, water chemistry such as nutrients, oxygen and carbon parameters, and also sediment chemistry, which includes organic pollutants, trace metals and benthic macroinvertebrates. Sampling was originally carried out in the Irish Sea on the east coast of Ireland and was then extended into the Celtic Sea and off the west coast of Ireland in recent years.
This survey had its origins back in the early 1990s in a joint project with the UK looking at nutrient levels in the Irish Sea. I was on a ship called the Loch Beltra, quite a small ship. It was a very limited survey. Nutrients are very important because nitrogen and phosphorus are essential elements for plant growth, so they underpin the whole food web. However, too much nutrient, say from land runoff, inputs from agriculture, particularly in coastal areas, can cause problems. So we are looking at nutrient levels to see, well, first of all, how they're changing in response to changing inputs from the land and changing practices on land. But secondly, we're also interested in how they change from different climate conditions. That survey switched to our new ship at the time in 1997, the Celtic Voyager, which was a huge step forward for us and allowed us to do much more work inshore and get around into work in much worse weather. So we extended that survey, and over the years that survey has continued to extend, so that now we cover, over 2 years we cover the entire coast. 1 year we go south about from Dublin to Galway, the next year we go north about from Dublin to Galway. We've also over the years made this a much more multidisciplinary survey, and we've improved how we do things. So we have added a whole suite of different parameters that we're looking at in the environment. So we are looking, for instance, how carbon is taken up by the oceans and the seas and how that will change the acidity. We are looking at pollutants in the sediment, how they're changing with time, so things like metals or pesticides. We are looking now at benthic fauna, they're the animals that live in the sediment, and what their distribution is like in different bays and in response to pollution pressures. And this year we even did a little bit of sampling for colleagues in Galway Mayo Institute of Technology looking at litter in sediments. So it's quite a range of different activities are taking place on this, what has now become a multidisciplinary survey.
So the main chemical parameters that we're sampling on these surveys are dissolved nutrients, salinity, oxygen, dissolved inorganic carbon and total alkalinity. And the main instrument that we use to take these samples is called the CTD, and it's a large frame that has Niskin bottles that are mounted around the frame, and we lower the frame through the water column and we can fill it at any depth that we choose from the surface down to the seafloor. and the frame has different sensors mounted on the bottom that tell us information about the surrounding water, such as temperature and salinity. Back on the deck, we then sample for the various chemical parameters. The first sample that we must analyse, or that we must sample, is oxygen, because the seawater is quickly contaminated with oxygen in the surrounding air. And we fill a glass bottle using a tubing, careful that we don't introduce any new air bubbles into the sample. And then we add chemicals to the sample bottle that fix, or they combine with all the oxygen in the seawater. We then analyse these samples on board using a Metron titrino and electrode that we used in a titration to determine the oxygen that was originally present in the seawater sample. So the next sample that's taken after oxygen is the inorganic carbon sample, because these are also contaminated with carbon dioxide from the surrounding air. And we want to measure the dissolved inorganic carbon and the total alkalinity from the seawater samples to determine the impact of the increasing levels of atmospheric carbon dioxide is having on our ocean chemistry. We again fill a glass bottle with the tubing and making sure not to create any air bubbles in the sample. And we then add a toxic chemical called mercuric chloride that stops biological activity that would alter the carbon dioxide levels during the storage of the sample. The samples are brought back to the laboratory and we analyse it on a Vinta 3C at the Marine Institute. We would then take nutrient samples, and here we're measuring concentrations of phosphate, silicate, nitrate and nitrite, and we want to look at changes that have occurred in Irish waters over time. The sample is filtered through acid-cleaned filters using a filtration unit and a pump, and the filtered seawater is then poured into small tubes that are immediately frozen to stop any biological activity that would alter the nutrient concentrations during storage. The samples are brought back to the Marine Institute and they're analysed on a Scalar SAN nutrient analyzer here at the Marine Institute laboratory. So the last sample that we take is salinity, and that indicates the salt content in the sample. And they are collected in glass salinity bottles, which are first rinsed and then filled, and then we insert a plastic stopper that is to stop evaporation that would alter the salt content during storage. The samples are then brought back to the Marine Institute and they're analysed on a Gildline Portacell salinometer, and the results indicate whether the sample has more freshwater or marine water in that particular sample.
An important part of our marine surveys includes the sampling of sediments gathered from the sea floor. They're then tested for up to about 50 different environmental contaminants such as PCBs, BF4s, PAHs and pesticides. Many of the contaminants that we quantify tend to eventually sink to the sea floor, which acts as a reservoir for these types of compounds. Some of the contaminants are naturally occurring, like metals from the Earth's crust, while others may be products of human-induced chemical processes from industry or from consumer products. Many of the chemicals that we monitor are highly toxic and some are even carcinogenic, so therefore they can be extremely harmful to the marine environment and harmful to us via the food web. Sediments are collected using a heavy steel grab device which is dropped from the rear of the vessel that takes up about 5 kilograms of sediment from the ocean floor at any given time. The grab is then raised to the deck of the boat and the sediment is put into specifically treated containers for analysis. Contaminant concentrations will vary depending on whether the sediments are sandy or whether they're muddy. Our sampling focuses on the muddier sediments because this is where the majority of the contaminants are found. Individual samples are sieved using fine mesh sieves to isolate clay portions, which are then analysed using highly sensitive instrumentation. The sampling programme is conducted year on year in very specific locations, allowing us to assess environmental quality around the coast. Results are then reported nationally and internationally as part of various directives and commitments. This wider reporting in particular allows us to amalgamate data in order to give us a much better and broader perspective on environmental quality European-wide. This whole process allows us to monitor contaminant levels in our marine environment and to assess trends and any potential risks as a result of the pollutant exposure.
People probably don't realise just how important a healthy marine environment is to the health of our planet. But if we think of the oceans as 70% of the landmass of the Earth, in Ireland our seabed territory, which we are responsible for, is 10 times the size of our land area. Oceans, as well as providing food, but they also play a very important role, for instance, in climate regulation, biogeochemical cycling. So very fundamental processes take place in the ocean at very large levels. Of course, there are lots of pressures from human activities that act on the oceans and on our seas. Some examples might be pollution, say from land runoff, industrial pollution, maybe litter, fishing, disturbance and destruction of our seabed habitats, and of course climate change itself and increasing temperature, and something which we're only maybe in recent years becoming more aware of, the acidification of our oceans from uptake of atmospheric carbon dioxide from fossil fuel emissions.
As an island nation, Ireland has had a long-standing tradition with the marine environment. Having such a valuable natural resource, it is necessary that we understand the impact human-induced practices are having on our waters. Continuous monitoring of our waters by the Institute is essential, as even minute changes in ocean chemistry can potentially have disastrous consequences on marine ecosystems. Being able to monitor ocean composition and analyse trends over time provides us with more control so that we can protect our marine environment now and for the future.